Good morning, students. Today we are going to start Unit 3 called Free Electron Theory of Metals. First of all, we will discuss about the introduction part of Free Electron Theory of Metals. Let us see. The free electron theory is applicable for all solids, including with both metals and non-metals. It explains the properties of number 1, electrical, number 2, magnetic, and number 3, thermal properties. The third one is it divides into 3 types of stages. They are number 1, classical free electron theory, number 2, quantum free electron theory, and number 3, Joule theory. Let us discuss one by one. The first theory is classical free electron theory. Let us see this first of all. This theory was proposed by Lorentz in the year 1900. According to this theory, it explains that the free electrons moves in a random direction and it obeys all the laws of classical free electron theory. The second theory is quantum free electron theory. This theory was proposed by Sommerfeld in the year 1928. According to this theory, it explains that all the free electrons obeys the laws of quantum free electron theory. The third theory is zone theory. This theory was proposed by Bloch in the year 1928. According to this theory, the free electrons moves in a periodic field provided by the lattice. This theory is also called as band theory of solids. Band theory of solids. We all know that band theory of solids are classified into three types. Number one, semiconductor. Number two, conductors. And number three, insulators. The subsequent concept after finishing this is merits of classical free electron theory. Let us see how they are. Merits of classical free electron theory. The first merit of the classical free electron theory is it verifies Ohm's law. Second one is it explains the properties of optical concepts. It explains both electrical and thermal conductivities. The last one is it gives the derivation in between electrical conductivity and thermal conductivity. The next we'll go for demerits of classical free electron theory. Demerits of classical free electron theory. Let us see this. The first demerit is it does not explain photoelectric effects, Compton effects, and black body radiation. The second demerit of classical free electron theory is it does not explain the conductivity of electrical and thermal. The third demerit of classical free electron theory is it does not explain the theory of ferromagnetism. These are the demerits of classical free electron theory. Now we will go for the expression for electrical conductivity in terms of number of free electrons and their mobility. One of the most important essay question expecting from unit 3 of free electron theory of metals. Let us see this. According to this theory, we know that from Ohm's law, the current passing through a wire is directly proportional to the potential difference of the conductor or a wire. Hence, I directly proportional to V, I is equal to RV, where R is called proportionality constant, and we can give a specific name for this constant of proportionality is resistance of the wire. R is resistance of the wire. The force exerted on the electron in an electric field is given by F is equal to minus E into capital E, equation 1, where E is equal to charge of the electron, E is equal to applied electric field. As the frictional force acting on the electron and the collision between any two consecutive and V is the velocity of the free electron, then the frictional force can be written as F is equal to minus m into V by tau. I can call it as equation 2, where m is equal to mass of the electron, V is equal to velocity of the electron, and tau is equal to time between any two consecutive collisions of electrons. Now the net force acting on the electron is given by F is equal to minus E minus m into V by tau, equation 3. In steady state condition, and applying Newton's second law, the equation 3 becomes like this. Let us see how it will be. M into A is equal to minus E minus m into V by tau. Since F is equal to ma by Newton's second law, as we know that A is equal to first derivative of velocity of electron, hence I can write A is equal to dV by dt. Bring it and substitute in the above equation, I will get m into dV by dt is equal to minus E minus m into V by tau. In steady state condition, the velocity of electron is constant, then dV by dt is equal to 0. Substitute dV by dt in above equation. we get m into 0 is equal to minus EE minus m into v by tau. The left hand side term is 0 minus EE minus m into v by tau. I just bring this minus EE to left hand side. I will get EE is equal to minus m into v by tau. Taking cross multiplication, EE into tau is equal to minus m into v. Our ultimate objective is to get the expression for v, that is velocity of the electron. Therefore, followed by v is equal to EE into tau y m. Rearranging, we get v is equal to minus e tau by m into E. I can call it as equation 3. Here, V is called the drift velocity of the electrons. Actually, we have two velocities for electron. Number one, in absence of electric field, the free electrons moves randomly just like the gas molecules randomly moves in a gas container. That is the first case. The second case is in presence of electric field, the conductional free electrons are in opposite direction to the direction of applied electric field. Now, the drift velocity can be written as the drift velocity is given by V is equal to Vd. As we consider that V is equal to minus E tau by m into E, we simply substitute in place of V, I will substitute Vd. Then my equation 3 becomes equation 3 followed by Vd is equal to minus E tau by m into capital E. Equation 4. If n is the number of free electrons and Vd is the drift velocity of electrons, then the current density is given by J is equal to minus NE into drift velocity. That implies J is equal to minus NE into VD. That implies J is equal to minus NE into VD is equal to minus E tau by M into E. Bring it and substitute it there. We will get minus E tau by M into capital E. After simplifying, J is equal to NE square tau by M into E. That implies J is equal to rho into E, where rho is equal to NE square tau by M, called electrical conductivity. This sigma is called NE square. We can call this sigma as rho. Rho is equal to NE square tau by M, called electrical conductivity. In this expression, this N is called number of charge carriers per unit volume, and E is called charge of the charge carrier, that is nothing but electron, and tau is called time taken for any two consecutive collisions, and M is called mass of the electron, which is the required expression for electrical conductivity in terms of number of free electrons and their mobility. Now, based on electrical conductivity, we discuss of about the two definitions followed by number one, mobility of electron. Number two, relaxation time. Let us discuss the first one, mobility of electron. It is defined as the ratio of drift velocity of electron to the applied electric field. Therefore, it can be expressed as mu is equal to Vd by E, which is the exclusive representation for mobility of electrons. Or we can also call it as mobility of charge carrier. As we all know that electron is a charge carrier and its value is 1.6 × 10⁻⁻⁹ coulombs. We can represent the mobility of electron is denoted by mu, that is equal to Vd by E, where Vd is equal to drift velocity of electron. We can represent it as Vd is equal to E tau by M into E, and capital E is equal to applied electric field. The second definition is relaxation time. It is defined as the time taken for drift velocity decaying by 1 by E of its initial value. Repeating once again, it is defined as the time taken for drift velocity of decaying by 1 by E of its initial value. We can represent it as, it is denoted by tau called relaxation time. Next, we'll get the expression for tau. Expression for tau. According to drift velocity of electron, we know that Vd is equal to E tau by m into E taking cross multiplication. M into Vd is equal to E into tau into capital E. Tau is equal to M into Vd by E into capital E. This was the exclusive explanation and expression for tau. As I told you previously, that tau is nothing but called relaxation time. Therefore, here tau is equal to relaxation time. The remaining topics will continue in the next class. Thank you very much, students.